Hi, and welcome to this walkthrough of the current Adapt Builder or Adapt Origin or Adapt Authoring tool, depending on your preference, code base. I'm Dennis Heaney, a senior developer at Learning Pool. The purpose of this presentation is to give an overview of the technical structure of the Adapt Builder app as it currently stands, highlighting the modular approach and showing how the system stands together or hangs together. The idea is to help contributing developers orient themselves and hopefully get some feedback on the current architecture and to plan our way forward. I'm going to start with a high-level description of some of the requirements for this app. In many ways, the app is to behave like a CMS. Users should be able to create content, upload and edit assets, and publish their work. The system is required to be multi-user and multi-tenant, meaning we need a solid system for separation of data between tenants while allowing for the possibility of globally sharing or publishing some content. System has to be as pluggable as possible so the clients are able to deploy with a variety of configurations in terms of database, file storage, and authentication approaches, and also so that tenant admins are able to configure which plugins and extensions are available to users of that tenant. So at the beginning of the project, we decided to separate the builder into front-end and back-end. With that in mind, we settled on the idea of building the back-end as a Node.js app using Express, and with MongoDB using MongoJS as the default database. Earlier on, we looked at projects like Calypso, which is a node-based CMS, and that informed some of the early structural decisions on the back end. The front end is envisioned, or was envisioned, as a single page app, and for consistency with the Adapt output framework, we settled on using Backbone.js. Recently, we discussed whether it might be a good idea to use a hybrid approach where different single page apps are used for the dashboard and the editor, alongside some regular Express routes for tasks such as install and login. I mentioned I'm currently working on a branch that refactors the backend a little bit better to support that, and to make it easier to add routes to the system without having to go ahead and modify core code. We've also decided to use handlebars as our templating framework both on the back end and front end. This is really a developer preference, and also it's for consistency between the back end and front end. Express by default supports J templates, but it's very easy to plug in handlebars, and handlebars helpers are quite useful to have as well. Okay, so first we're just going to take a look at the lib directory, and here we have the core modules for the app, the main entry point being application.js, and this defines the Adapt Builder object or class, which is the main application object. So I decided not simply to have the app as an Express app, not to extend Express, instead opting for the HASA approach. So the app has a server member, which is actually the Express application. However, some of the Express methods are wrapped up by the Adapt Builder object. So you can see here we wrap up the get, post, put, delete, head methods. They're just wrappers for the Express server member. With the servers run, the builder loads the core subsystems here. So you can see these basically correspond to everything in the lib directory. Once those are loaded, the server is configured. You can have a look at some of the middleware that's being used here, and different configurations for development and production depending on the environment, and then the server is started. After that, the server started event is emitted. Other modules can listen to this to do anything they need to do at that time. So we'll take a look at some of those modules in a minute, but the first one I want to highlight is the plugin manager. That's our module for installing, managing, and retrieving most plugins. So plugin versions and some plugin configuration settings are stored in the database and managed using the plugin manager. So this module is not entirely complete yet. some of the persistence of plugin versions and so on isn't implemented. But I wanted to show you the get plugin interface here on line 136. So it takes plugin type, which would be auth, file storage, or possibly database, and then the plugin name. So it's the implementation. So it might be local FS for file storage and local for auth, or it might be S3 for an Amazon S3 file storage implementation. And so basically it memoizes or caches plugins, checks if the type and plugin name exists, and fires it back if it does. So it's basically your entry point for getting any of the pluggable components on the system. So just to mention quickly about our testing approach, we're using Mocha for testing. We're using SuperTest and SuperAgent for modules that need to use a HTTP request during tests. Core modules all have their tests inside the root test directory. In here, once it loads, you'll see there's a nice example, I think, the lib content manager that shows how you would use SuperAgent to make requests to the API. So there are some of the tasks when you run make test. Some of the before tasks set up a dummy account that you can use. So to create a session for making HTTP requests to the API. So you can see in here in the content manager tests, we have a before function which goes ahead, creates an agent, and posts the API login to set up a session. And then the tests in your sort of TDD or BDD format follow on here. So this, if you're not familiar with Mocha testing or SuperAgent, that might be a good place to understand how we've approached it. So we have a logger instead of using just console.log all the time throughout the code base, and also because we need to have logging persisted somewhere, either to file or to the database. We have a logger module. This basically wraps up Winston. I don't know if any of you are familiar with that. It's a npm package. It's very handy, and you can define, or you can add different transports. You can have multiple transports all operating at the same time, including console, some database transport for MongoDB or other databases, and file as well, which will write all your logging to a flat file. It seems to be pretty good at the moment. We default, I don't think it's in this branch, but at the moment it's defaulting to console. You can also log messages with different log levels, so your standard info, fatal, warn, error, and silly. So if you turned on debugging or something, that you'll get much more messages. So use that rather than console.log if you're developing any modules. So I'm just going to quickly cover database setup. So the database module exposes the database constructor with abstract methods, connect, load schemas, add model, get model, create. And so that's create, retrieve, update, destroy. Is your CRUD. I didn't call them create, read, update, delete, just because I didn't. But we have only one implementation at the moment. It's basically a database plugin, which is in libdml mongoose.js. Mongo being very popular, MongoDB being very popular, and mongoose.js being a really handy library for managing it. You can add schemas and get content validation, and yeah, it's just a bit of a lightsaber. But at the moment, whenever a database is instantiated, it loads any schema from file. So system schema are kept in lib content schema. Sorry, they're in libdml. libdml schema system. I'll just take a quick look at some of the schemas that are in there, if this loads. So I'll have a look, for example, at a tenant schema. So those are the attributes for a tenant: a name, database, which is an object which supports DB name, host, user, passport. They default to whatever the system database settings are. But you can see it's a Mongoose schema at the moment. However, we are implementing our own schema format. So this is going to change. Rob can tell you a wee bit more about that. Rob Moore from Learning Pool. He's working on JSON schema definitions at the moment. So basically, the database is any database implementation will need to be able to read our schema format and convert it to whatever format it likes to use. So Mongoose is going to have to read it and convert it to Mongoose schema, for example. I'll also show you the database module itself has an interface called getDatabase. So this is an async interface which plays into how we manage our multi-tenancy approach. Let me just take it down here. So typically you just call database get database with a callback, which receives an error, and database object if returned. So that's important when I'm talking about our multi-tenancy solution. We decided to implement multi-tenancy using a single database per tenant approach. This means that we're storing user records in a master tenant, but users are mapped to their own tenant after logging in. So we do this by storing the user's tenant ID in their session, and then in this interface we get the user session, and we get the tenant from the user session, and we use that then to retrieve the database for that tenant. So it connects to a unique tenant, or we create the database if it doesn't exist using those settings. So you can see here we basically require in the pluggable database, or the database module, instantiate it and do whatever setup is necessary here and return it. So this seems to work pretty well so far, but I'm not quite sure how well this will scale up, and also if we need to manage the number of database instances that are in memory at any time. That's something we've got to test or talk about as we go along in the development. I think this will do us for release 0.1 though. I will say that we are using the experimental Node.js domain package to access the session here. This is because get database can be called anywhere in the system, and we won't necessarily have access to the current request. We don't want to pass it down through a load of functions in order to get access to it, so we can access the session. So what we do is there's a bit of middleware that when a request comes in, it instantiates the domain and attaches the session to it. That allows us to access it here in this piece of code. I'm not sure if that's the best approach. It seems to work, but again, that's something that we maybe need to look at. Maybe someone will have more experience of handling something like this and give us some tips. Another important feature of the multi-tenancy are permissions, managing permissions. So we've unashamedly ripped off our permissions approach from Amazon's AWS policy file format. So basically a user's access to a resource is controlled by a list of statements which identify an effect, which might be allow or deny, an action, which is usually create, read, update, or delete, and a resource identifier. So presently, this is only implemented as a broad-faced permissions check via the REST API, which I'll talk about later. And it's implemented as a connect/express middleware function. So client makes a request to an API endpoint, say API/user/user ID with one of the HTTP methods, put, post, get, or delete. And the permissions module builds it's still loading here, builds a resource ID from the current tenant and URL, and loads the user's policy statements, checks them against the resource to determine if the request should be allowed to proceed. If the user is allowed, if the action is allowed, the middleware just hats off to the next function. Otherwise, a 403 response is sent back. So, while we're waiting for this to load, I'll just briefly explain that a resource attribute in a policy statement can be a glob pattern. So, for example, you can have tenant ID/star that basically allows, and if you set allow as the effect for that, that will allow the user whatever the action is, create, update, read, delete. That can actually be an array, so you can actually allow all actions within one statement. So the /star will capture all actions within the system. So effectively your admin user has allow set with create, update, read, delete with all tenants /star can do anything in the system. Well, that's super admin. Obviously, tenant admins need to be managed differently. Anyway, there's still a lot of work to do on it, including whether we cache or memoize the results of permissions checks. Possibly that can be done in the user session data. I don't know if that's the best way to do it, especially since we're storing session data in the database. Session data is being stored in the database. But we also need to be able to build custom roles from a collection of policy statements, so a template basically of the policy statements that we can assign to a role, and then assign those roles to different users. We also need to write a user interface for editing those roles and permissions via the dashboard. And for version 0.1, we're aiming at only having a single tenant, single user setup with full admin access, so all that editing functionality can really wait until we move to build version 1.0. But it's important to sort of keep in mind that we may need to put permissions checks throughout the code. Now, like I say, if it's going through the API, there will be a broad-faced check anyway, but we may need to filter results. For example, if we access a collection that's global to a tenant, then we may need to filter out some of those results, which can be done with finer grain checking using the has permissions method of this module. So anyway, here you can see you can actually add some patterns for routes to ignore. Probably kind of look a little bit like Apache htaccess patterns. So at the top of this file, there's just a little policy parser object, but I'll get down to the middleware function, which is kind of the important part. Well, that's has permission, which runs through a user statements and decides whether this user ID is allowed to perform this action on this resource. But here, policy checker is the middleware function, and if you're familiar with middleware function syntax, this should all look pretty normal to you. We check if we should ignore the URL and pass on if so. Otherwise, if the user doesn't have a valid session, we get a 403 immediately. Other than that, we create the resource string from the tenant ID and the request URL, and then the action from the request method. Those need to be remapped. I think they're incorrectly mapped for RESTful, so I think put is mapped to create instead of update. Anyway, and then has permission is called, and if the user, if we get an error, we get a 500. Otherwise, the user's allowed, and it goes through to whatever the end point of the route is. Otherwise, we get a 4.3. So that's that. Hopefully that makes sense. I'll not get into the details of how the resource strings are built. You can look at that if you want later. Authentication. The auth module is really just a wrapper for Passport.js. It seems to be the most popular node package for managing authentication as far as I can see. Maybe other people know better. But it's another pluggable interface. So we define the constructor here with a few methods that need to be implemented. So at the moment, auth local is using the local passport strategy, and there are other OAuth passports and other passport strategies available. If someone wants to implement them, they'll have to build a plugin for them. I think they'll probably be wanted for version 1.0, one or more strategies, so it's pretty important that we start thinking about that after version 0.1 or maybe even before. So I should just say that for hashing passwords, we're using bcrypt for crypto, but we're using a pure JavaScript implementation. Is it this one? I think there's Node bcrypt, and bcrypt Node.js must be a different module unless someone has updated that. The reason I opted for the pure JavaScript one was because earlier on some developers using Windows were having problems because the Node bcrypt module requires it has a dependency on OpenSSL in the system. I think we need to change that, or we need to decide on a different crypto method. I tended towards bcrypt Bluefish because our sysadmin recommends it. So obviously content creation being the main object of the authoring tool, we have a module called Content Manager. So this basically automatically sets up REST endpoints for content creation CRUD by reading in content schema from disk. You see you can add them here. At the moment, this means to enable a content type for editing, you just drop a schema into lib content schema and restart the server. This really was just done for convenience to help sort of shuttle along the front end team so that they could have some collections that they could point their models to for creation and updating and so on. It needs to be completely overhauled. In particular, an open question is we need to allow plugins to be installed and to add new content schema while the app is live. We don't want to have to restart the app in order to do that. Additionally, anytime a new tenant database is instantiated, we need to allow that instance to load all the schemas that are known to the system. So we might be able to do this with event emitters, but it's an open question again, and we don't know how well that approach might scale. Basically, Content Manager uses the schema name as a parameter to forward CRUD to the database. So if it knows there's a particular content schema in the system, well, if we can look into this, you'll see the endpoint is /API/content/ say for example project if there's a project.schema in the content schema, and it'll handle it basically based on put, post, get, and delete. It decides what the action is that time. It also does collections if no ID is provided. Anyway, so that's where you can go to look at how that hangs together. I think we'll just cancel that loading if we can and maybe go and look at the REST module. Yeah. So this is basically all the API routes are built and managed through here. So if you want to add something that's really part of the REST API to be accessed using the single page app, and it's JSON in, JSON out, you use the REST module. So you can do rest.put, rest.get with your root and your handler, similar to any Express route. One of the early problems with this was that I wanted to be able to allow you to add REST routes at any time during the lifetime of the app, so before the server had started or after the server had started. if you're familiar with middleware, you might have come across a problem where if you add a root before you've started your server listening and before you've added some middleware, that root won't actually use the middleware that you later add. So in order to handle that, we actually queue up, we actually add any new routes to a queue if the REST module has not already received the server started event. Once the server started event is received, it processes that root queue. That's what's happening here. So that's kind of a whistle-stop tour of the code base. There are probably a few things that I've left out, but for brevity, I don't want to go into everything. But I will say our immediate to-do list includes defining a component plugin type. So this is to allow adapt framework contrib plugins, when they're added to the system, to be picked up by a component plugin instance, to add that to the database, get the schema from that plugin and make it available for editing through the content manager. We need to define, Robmer is currently working on defining the JSON schema that those components will use, and probably will be used by other types of extensions to the system. Extensions might be, for example, a workflow plugin. So this is to modify the behavior of the adapt builder app, and rather than exposing a new content type for editing. We also need to develop the REST API. At the moment, it's really just get, update, read, delete, and there's no parameterizing to that. So we need to accept JSON so you can search and sort and whatever else is useful, and also add some custom REST endpoints that batch up some operations. For example, joining users to projects so that you don't have to make multiple requests to find out which user maps to which project and so on. And also we need to work out how we're going to manage attaching schemas to the databases whenever the databases are instantiated. So for example, when a new tenant database is created, the schema can be anywhere in the system. It must know how to go off and fetch them. So any ideas in that front are very welcome. Otherwise, we'll just use we'll allow any module just to listen for a database instantiation event and then go ahead and populate it with schema that it's read from disk or knows about. We also need publishing plugins, so a publishing plugin type. That's probably something that'll require a core sort of class here that can be extended and implemented. So obviously our first plugin, publishing plugin type, will be adapt framework, so that you can import an adapt course, have that populate the database with assets and with the JSON, with the components that have been added, verify whether all the components that are needed are installed in the system and so on, and also to allow us to export whatever the user has created as an adapt framework plugin. But on the roadmap, people are asking on the forums for the ability to import and automatically create a course from a Word document, or to export your course as a Word document, and maybe PowerPoint, and also Captivate if we really want to do that. Also, it's important, I think, to support down the line remote repositories. So that'll be the like of Amazon S3 storage or something like that.